All right, so in the next type of problems involve two dimensions. So in this case, the forces are not all along a sort of straight line. They have different angles to them. The method is the same. You're drawing your free body diagram, but now you kind of want to draw in your x and your y axis, and you want to break each of the vectors into their x and y components. Then, just like we did with position vectors, you would add or subtract the vectors in the x and y directions and get their sum. Okay, so in this first problem, two students are the same, like maybe the same two students are pulling the crate across the alley. This time there's no friction, but you can see that they're pulling in their own directions. So student 1 is pulling at a force of 150 newtons at an angle of 30 degrees above the horizontal, or above the direct east line, and student 2 is pulling with a force of 110 newtons, 20 degrees, like I guess you would say east, 20 degrees south. Okay, so we have to, there's different ways to do this. You could use the tip to tail method, which is starting with the 30 degree. This is 150 newtons. And this is 30 degrees. And then adding the 20 degree. So maybe like this. This is 110 newtons. And this angle here is 20 degrees. This angle here is 20 degrees. So this is kind of the resultant is what we're interested in. We're interested in this vector, right? This is F net. So you can do that by adding the horizontal and vertical components of each of these vectors. And what that is for the first one, so let's just draw each of them in separately. So here's 150 newtons. And then we have the x component and the y component. And then the angle itself is 30 degrees. Okay, so we can say F1x is equal to 150 cosine 30. F1y is equal to 150 sine 30. Right, and then you can find those numbers. I'll just put them in here. So 150 cos 30, that's 129.9 newtons. And then 150 times sine 30 is 75 newtons. All right, so then looking at the next vector, we've got the 20 degrees. 20 degrees, this is 110 newtons. Hang on, let me redo this. So this is 110 newtons, and then the angle is 20 degrees. So let's be careful about this, and let's think a bit in terms of directions. So it's the x-axis, the x component is pointed in the positive x direction, but the y component is pointed in the negative. You see it's opposite? This is F2y. This is F1y. And F1y is pointed up, F2y is pointed down. F1x is pointed in the right direction, and F2x is pointed in the y direction also. Okay, so just solving for these two, F2x is equal to 110 cosine of 20 degrees. And then F2y is equal to 110 sine of 20 degrees. But it's going to be negative because it's pointed downward. I'm just putting the 20 degrees, just treating it like the magnitude. I think if you just put in negative 20 degrees, it would actually work out. And you would get the negative number. That's another way you could do it. Times cosine of 20. So this is 103.366 newtons, and then 110 times sine 20 is 37.622 newtons. Okay, so let's put it all together now, and we want to find the F net x is equal to F1x plus F2x. and that's just equal to 129.9 plus 103.366. And that equals 129.9 plus 103.366, 233.266. All right, and then F net in the y direction is going to be, so we're going to subtract, but I mean, you can think of it as adding the negative. So it's going to be F1y minus I'm just going to put plus F2y, and then we can put it in, because it's the sum, but since the direction matters, it's going to be 75 newtons, and then we put down here, put negative, I should have included that here, net minus 37 point, so I could say, I guess to make it completely clear, I could say plus negative 37.622. If this is confusing, please ask me about it when we meet next class, and we can go over it together. So 75 plus, subtract 37.622 equals 37.379. So what I have now is the x and y components of F net. So now what I can do is just the same method we've used before, in that I have the x component of F net. This is F net x, which equals 233.266, and then I have F net y, which is much smaller, F net y, and that equals 37.379, and that gives me my resultant F net, the full F net. Okay, so then to find F net, I'm just going to use Pythagoras, which is the square root of 233.266 squared plus 37.379 squared, and that equals, so let's do this, answer squared plus squared, we get 236 newtons. So my net force equals 236 newtons, but it's never enough just to put the magnitude. We also, remember, we always want the angle, and we find that by using tan inverse. So theta equals tan inverse of, and we can say 37.379 over 233.266. So theta is equal to, let's see, so 37 divided by 233 second tan equals, the angle is 9 degrees, 9 degrees, or 9.1 in my calculation. So what we're finding is it's a positive angle, so it's up, right? So then my answer would be, if I was to write this out as a statement, F net is equal to 236 newtons, and then I would put in the direction, it would be east 9 degrees north, according to that diagram. So that's my final answer, and it's taking into account the directions of the different vectors and which direction is the final net force pointing. Okay,